Now, what you could do before you even start, which I wasn't doing it on those, but I could do it, all right, might prevent you from missing an answer. You can think of this as, okay, before I even start the problem, what are my restrictions on X? In other words, what can X not be, okay? Or what does X need to be to make this equation true? All right, if I look just at this right here, X has got to be bigger than what number? Because if it's not, this will become negative. So X has to be bigger than what number? That's your thinking. X has to be bigger than -6, because if I plugged a -6 in there, then I would have 0. We can't take the log of 0. All right, if I put a -7 in there, that whole expression would be -1. Okay, so it might be a good idea to go through and think about those restrictions before you even start it. Over here, X would have to be greater than -2. Because if I put -2 in there, I get 0. If I put -3 or -4 or -5, I get negative numbers in there. All right, so think of those as restrictions. We've talked about restrictions before, restrictions in our domain, restrictions just anywhere and everywhere. We've talked about restrictions. So it might be a good idea to think about that before you even start. Okay, now, what I'm going to do here, we learned one of our log properties. When we see two logs, same base, and we're adding, we can compress that into a single log, right? So when we add, it means to multiply, okay? So here, I'm going to use my log rules. I'm going to compress that into a single log. So I'm going to have the log with a base 5 there, and I'm going to show those two things multiplied together. So x plus 6, x plus 2. And if you want those square brackets around there, that's kind of maybe a good idea. Say you're taking the log of this entire expression. Now I have a single log equation, right? And in that last example, what did we do? When we had just a nice little log expression, we went to exponential form. All right, so if you can get it down to a nice single log like that, then you can turn it into exponential form. So this will be 5 raised to the first power is equal to x plus 6, x plus 2. And again, when you get to that point, hopefully then it's a straightforward solve that equation. All right, on the right-hand side, can I FOIL that out? I'm going to end up with a quadratic. All right, so let's FOIL it really quick. X squared. Can I do the next two in my head? 6x plus another 2x is going to give me an 8x. And then 6 times 2 is going to give me a 12. And then to solve a quadratic equation, everything needs to be on the right-hand side or the left, but I'm going to leave everything on the right. So I'm going to subtract 5 from both sides. So x squared plus 8x plus 7. Easiest way to do this, I mean, you could do quadratic formula, you could complete the square, but this one's going to be what, easier to factor, right? To solve the quadratic equation, we're going to factor. Those other methods would work. This is just going to be the easiest way to do it. Everything is pluses, factors of 7 are 7 and 1. So those are my only choices. All right, here I get x is equal to a -1. Here I get x is equal to a -7. But I said up here x has to be greater than -6 has to be greater than -2. Which one of those do I need to throw out? The -7, because if I plug a -7 in here, -7 plus 6 gives me a -1. That would make me trying to take the log of a negative number, and I can't do it. So I can look at my restrictions, and I can tell I need to throw this out, which means then my only answer in set notation is like that. X equals -1 if you're writing it in that form. Here, if you're writing it in set notation.